Hey guys. Um, so today we're going to start talking about something slightly new. But of course, just like everything else we've done this year, it's going to be rooted in something that we've already previously discussed. So as you can see from the title here, we're looking at systems of equations. And specifically, what that means is we're looking at situations where there's more than one equation that we're looking to satisfy a value of. So if we think about for a moment an equation that looks maybe like this, y equals 2x plus 4, we know that there is an infinite number of inputs and outputs that will make this statement true. For example, if I had an input of 0, then 0 times 2 is 0, and 0 plus 4 is 4. I would get an output of 4. And the reason why this coordinate is a solution to that equation is if I go back and plug those in, is 4 equal to 2 times 0 plus 4? Is 4 equal to 4? And of course the answer is yes, it is. So 0, 4 is one solution to the equation y equals 2x plus 4. Can you come up with another solution for the equation y equals 2x plus 4? Specifically, if I give you an input of 6, an x value of 6, can you tell me what the corresponding output or corresponding y value would have to be? Right, so if I plug 6 into my equation, I'm going to get 2 times 6 plus 4 is equal to y, which is going to give me 12 plus 4, which is going to give me 16. So input 6, output 16. And there's an infinite number of points that will continue to give me those solutions. And when I graph all of those possibilities, I end up with some kind of linear function. We end up with something like this, starting at 1, 2, 3, 4, and going up to and over 1, and up to and over 1. And we get some kind of linear function. And we know that that linear function is really just all of the individual points that we would be able to find in this chart. Represents all of those specific values. So in a system of equations, we want to understand all of that same information. We want to understand that every equation has a set of domains and ranges which will make the equation true. And in a system of equations, we're going to be looking for a situation where there is maybe more than one of those, where a particular point, that is going to be valid, or it's going to be a solution for two different equations. So, for example, can we come up with any other equation that would have a value, plug in 0, get out 4? And sure, like an equation that looks something like y equals x plus 4. The equation y equals x plus 4 would also use that point 0, 4. We would say something like 4 equals 0 plus 4. Does 4 equal 4? It does. And if we think about what the graph of that equation would look like, if we think about the graph here, the slope is 1 over 1, and the intercept is 4. So it's going to start at 4, and it's going to go up 1, over 1, up 1, over 1, up 1, over 1. It's going to be a little bit flatter than my original line, but we notice that that yellow line and that green line intersect at a single point. And that point is, of course, 0, 4, input 0, output 4. And that point represents the only place on my graph where this equation and this equation are both simultaneously true. At the exact same moment, at that 0, 4, both equations are going to be true. So our goal in this lesson is to use graphing to figure out the solution to a system of equations, to look for that one point where both things are going to be true. So let's try an example here. I'm going to give us two equations. And one equation says y equals half x plus 3. And we'll go with the other equation saying y equals 2x, and let's use, y equals 2x. No intercept there. So let's look for the point where both of these are going to be true. And certainly one thing that we could potentially do is make a chart and start charting all of the possible values for x and y in this guy, and all of the possible values for x and y in this guy, and try to find one where they match. But unfortunately, that's probably going to take us a really, really long time to check all of the points on this line. In fact, we can't ever check all of those points because it is, of course, infinite. So rather than doing that, we're going to use a graphing approach. We're going to use a graph instead. So let's look at our first equation, and we're going to make this our green equation. What do we know about the slope and the intercept of this equation? Well, we know that the slope is 1 over 2, and the intercept is 3. So I'm going to start at the y-intercept of 3, and I'm going to go up 1 and over 2, and up 1 and over 2, and up 1 and over 2. Something like that. I could also, of course, go down 1 and left 2, or down 1 and left 2, or down 1 and left 2. Something like that. And we're going to get this connection of points that we can, of course, draw a line through. And you are, of course, going to use a ruler to do this. I'm going to do my best to make a straight line on the board here, but I certainly would like for you to use a ruler for this. Cool. So that's what's happening with our green equation. There's all of our values for our green equation. Now let's check out our yellow equation, y equals 2x. Well, what do we know about the y-intercept and the slope of this guy? We know that it has a y-intercept of 0, and it has a slope of up 2 over 1. So we're going to go up 2 over 1, 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 or down 2, left 1, down 2, left 1, down 2, left 1, etc. We get all these nice points. We do our best to connect it with a straight line. Of course, you're using a ruler. I apologize for the crookedness of that line. In fact, I'm even going to redraw that line because I really don't like it. So let's redraw that line. Let's go ahead and connect it like this. I still don't love that line, but it's a little bit better. And what we notice is that the two lines intersect very nicely at this one pink point right here, and that point is sitting at 2, 4. So my solution to this system of equations is going to be 2, 4. Well, let's see if that makes sense. Let's plug that in and make sure that it's true for both of my equations. Let's go down here first, and we're going to say, is 4 equal to half of 2 plus 3? Is 4 equal to 1 plus 3? And yes, of course it is, so that's true. And is 4 equal to 2 times 2? Is 4 equal to 4? Again, of course, it is. That is the one point, 2, 4, where these two lines intersect, which means it's the only place where the solution to the green line is going to be the same as the solution to the yellow line. Let's do one more example together here. I'm going to ask for some input from you on this. And in fact, I'd love if you had your graph paper notebook out. And if you just kind of maybe worked your way through this question ahead of me and gave me some thoughts on what your answer was. And if you're not sure and you want to double check, I will, of course, go over it in just a moment. So let's look at this equation here. One of them is going to say y equals 3x minus 1. And the second one is going to say y equals half of x plus, let's go with 4. Let's do that. And let's try to figure out what the solution to this system is. So let me ask you first, in your own words, how would you graph the yellow equation here? How would you graph that yellow equation? What steps would you take? Cool. So in order to graph this equation, certainly we're going to start at the y-intercept, which is -1. And we're going to go up 1, 2, 3, and over 1, up 3 and over 1, up 3 and over 1, or down 3 and left 1, down 3 and left 1. And we can connect those yellow points together. And again, I really, really apologize for how awful that line is. It's hard to do this on the board. And we're going to go now take a look at our green line. what do we need to do in order to graph our green line? Give it a try. Cool. So looking at that green line, we're looking at y equals half x plus 4. It means we're going to start with an intercept of plus 4, and we're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2, or down 1 and left 2, down 1 and left 2, down 1 and left 2. Connect my green dots. And we have found an intersection point. We found one particular point that both of those share in common. I'm going to go ahead and color that in purple real quick. And that point is sitting at 2, 5. Now, is 2, 5 an actual solution here? Let's just double check. Let's plug it in and see if it works for the first, and let's see if it works for the second equation. Go for it. Yeah, so it works for both equations. Let's take a look at that really quickly. We've got, is 5 equal to 3 times 2 minus 1? Is 5 equal to 6 minus 1? Yeah. And is 5 equal to half of 2 plus 4? Is 5 equal to 1 plus 4? Again, yes it is. Okay, so 2, 5 is in fact that one point where these two lines are going to meet. Just really quickly, I want to mention one other thing to you. And that is to just think about that there is potentially a weird possibility where I might get no solution, where I might get no intersection points. What do you think it might look like? What would my graph have to look like for us to get no solution to a system of equations? Right, so it would have to be parallel. If my lines were parallel, they would never cross. There would be no solution that they have in common. And what do we know about lines that are parallel? What do we know previously about lines that are parallel? Yeah, so lines that are parallel need to have the same slope. So anytime my two lines have the same slope, there's a chance I'm going to get a no solution because the lines are parallel. But there's also one other weird possibility, and that is the possibility that both lines are exactly the same. And if I graph two lines that have the same slope and the same y-intercept, those two lines are going to be lying directly on top of each other. And when those lines lie directly on top of each other, they don't only intersect once, they intersect an infinite number of times. So when we're dealing with system of equations, there are three possible things that we could be looking for. Thing one is we're going to look for one solution. And that one solution is going to be given in the form of x comma y. And that's when those two lines cross one time. We might get a situation with no solution, and that would occur only if the lines were parallel. And we might get a situation where we get all solutions, or infinite solutions, and that's going to occur when the two lines are lying directly on top of each other. So we will continue to discuss this tomorrow in class, and we'll introduce some more things about system of equations and work through some examples. But I hope this was a good introduction for you guys, and I hope that everything that we've talked about in this video makes sense, and I'll see you guys tomorrow.